Okay. So thank you everybody. Thanks for being here. Even though we're out of pizzas, you guys still stick around. So that's thank you. My name is Omri. I want to talk a bit about the top mistakes people do in data science interviews, preparing for the interviews. And since we're working on data science, let's start getting some data. Who here works now as a data scientist? Very few. Okay. Who's thinking about becoming data scientist? Okay. Who's here for the pizza? Who here took end-to-end Coursera course? Okay. Nice. Software developers. Nice. Data analysts. Anybody from non-computational mathematical stuff? BA in arts. Who's the coolest person around here? Okay, definitely not. Okay. My name is Omri. I'm currently the head of research at Omri Allouche. I teach data science at Bar-Ilan University. I did my PhD in ecology. Okay, completely different. And my undergrad was in biology and cognitive sciences. So in a way, I also took an unorthodox route into data science. And I'm not going to talk about my transition, but I think that part of the things that I'm going to talk about relate to how you can make such a transition and go into this. So just a quick overview of GONE, because it's related to most of what I'm saying here is based on my experience interviewing for GONE. GONE is a startup company, exists for less than 3 years, but sells very well already to big clients like LinkedIn, Pinterest, General Electric, and more. One of the fastest growing companies in Silicon Valley, definitely in Israel. Huge buzz around the company. We currently have 12 people in the research team, or say 65, almost 70 people in the company at all, growing very fast. You can see here the chart that places GONE among other competitors. And the interesting thing about GONE is what we do and how it relates to what we are looking for in data scientists. So GONE helps sales teams improve by providing actionable insights on what top salespeople do that others don't and can learn to do. What does that mean? We automatically record, transcribe, and analyze sales calls, and then give insights based on those things. So we analyze the video of the call, okay, and we can give you insights as to what's happening in each part of the conversation. Are you sharing your screen, or are you sharing your webcam? What's better? Should you share the webcam, or should you show a demo? What works better? We have our own speech recognition engine. We transcribe calls, okay, and then we start analyzing everything about them. Lots of NLP, lots of statistics around things, in order to provide more and more insights into those things. We don't take anything off the shelf. Okay, we have to develop everything ourselves, including the speech recognition, which has makes half the mistakes Google does, for example. And I think that a lot of what we see here is that we are looking for people that would be able to do a large variety of things. And I think that is part of what we see in the industry in general. So I want to go over the top mistakes and misbeliefs that I think people are doing when preparing for data science interview. And I think the first one is that people don't really understand what data science is. And that's understood because nobody knows what data science is. Anybody here thinks they know what data science is? Okay. So the best definition for what data scientist is, a data scientist is a data analyst working in Silicon Valley. They now allow to include Tel Aviv and partially Herzliya as part of that as well. But seriously, if I look at just random data science related job posts, you can see a very large variety of those things. I don't really understand what people mean by those things. Okay, so I have here data scientist, machine learning engineer, classification science. Okay, so you only do classification, or Python API developer. There's really a big variety of those things, and it's really, really confusing, especially when you're trying to enter the field. Okay, you don't really know how that works. And in order to be a good data scientist, you need to know tons of stuff, okay? Like everything that's written here. Okay, I don't know if you guys seen that. I'm not going to go over those things, but basically what they tell you is that you need to know all of those things. Nobody knows all of those things, which kind of leads to, if I won't know all of those things, maybe I don't have to know most of those things. And the feeling that's around for people that doing interviews is that everybody wants to be a data scientist nowadays. You don't really, okay, you make the transition and you learn, okay? And this is something that's a bit against you when you're trying to apply for a data science position. You need to understand that, okay? There are a lot of people that are very talented, want to make the transition. How would I know if somebody is just riding on the wave of buzz and somebody who's really made a serious decision of where they want to have their career? So the first thing that I think you need to understand is that when you put in all of those things together, I will go in more detail into this Venn diagram, you do need to know all of those things. Okay? You don't have to know them very well, you don't have to know them when you're just starting, but you will have to go over all of those things and get to a good level of them. And it's important to identify what you know and what you don't know, and handle those things. But any position that you'd apply to, anyone that would work on any job that you'd work, there's a different balance of those different skills, okay? And you won't learn it from the title of the position, and most of the time you won't even get an accurate understanding from the job description, okay? You need to ask, okay? Seriously, talk to the HR person and ask him, her, okay? What does that really mean, being a data scientist at your company? If you're applying for a junior one, for a machine learning engineer, consultant, regression sciences, understand what that means, okay? And companies should be able to provide you with understanding of what that means, because that's what you're going to do for the rest of, for a year, for two, hopefully a lot more. So I know that it's difficult to get into the field. I know that for many of you that would be the first position. Don't be like this, okay? It's like, okay? The market now, there's a huge demand for data scientists. And yeah, it's frustrating, starting, I don't have enough experience. I had one of those, we're looking for someone 22 to 26 years old with 30 years experience. That's the feeling you get in most of these times. But you want to make the right move and do those things here.
I saw 15 years experience in deep learning.
Yeah.
That's the best one I've seen. And usually the HR team knows nothing about it. So
I saw 10 years experience in Java in the year 2000.
Okay, so another thing that I see candidates do, okay, when when doing the transition to data science, is to running away from those superpowers. You're a software engineer, you're very good as a software engineer, use that. Don't discard that, don't say, I don't want to do that, I'm making it from transition, okay? You're not starting from blank, you have a lot of experience, understanding, use those things. And in the balance of all of the things that you're trying to do, that you should know, okay, it makes a lot of sense that you won't be the best data analyst if you know software engineering well, okay? Or that you will learn how to be a better software engineer, okay, or write better code if you know really well how to do research, how to do data analysis, okay? But understand that, don't run away from that. It sounds really obvious. Most of the people I'm talking to are saying, I don't want to do what I've done before. I want to do something completely different. I don't want to touch that. I want to relate to that. Okay? And I think it's a big mistake. Big mistake. Okay? And it's basically my brain over there. Another thing, another mistakes that people do a lot is optimizing their own loss function. What I mean by that, okay? Oh.
Is this in the interview?
Okay. So you need to understand. I'm going to take 5 minutes to work on those things here. I'll explain what I'm trying to do here. Okay. This is going to be your job. Okay? Forget about I'm working at the circus, so the zoo, it's so awesome. You need to understand what you're doing. Okay? You need to understand that you're not going to do it for years now. Okay? So data science is cool. It pays off really well. Don't make your loss function, I want to make the most money in the next year or 2 years, okay? You're young, all of us are young, okay? Except for those that had 15 years experience in deep learning, okay? Try to find a place that will help you grow and learn, okay? And that's the most important thing that you need to do right now. And there are several restrictions and rules that you need to follow. Okay, so understand that you're not Kobe Bryant. You're not skipping college in order to just go directly to the NBA. Okay, you're trying to build yourself, to learn the skills, to be able to play in the big pros game, which means that you need to find a place that has people that are smarter than you and that are more experienced than you. Okay, which makes a lot of sense if you're just starting. But there are many companies that have just one data scientist in the team, or they don't have one. And it sounds super interesting. Oh, there's lots of data, lots of things that can be done. I say, don't really, okay? Don't go for these opportunities when you're just starting out, okay? And understand that your goal is to learn and to improve and to get better in a few years, okay? You have a lot of time, the field is moving super fast, and the foundations that you learn right now will have a huge impact on your career. So all of this is just in order to make sure that you don't get this situation, because most of the people that I talk to, okay, don't really have questions about the company, the position, and all those things. Make sure that you do, okay, because this really helps to understand what you're doing. I'll give you another example. I'm really surprised that nobody asked me to do that so far. Okay, half a day, 1 day, when it's serious and you know you're considering 2 or 3 positions that you got, half a day or 1 day working at the company that gives you some computer, you understand what it really means to do the work, shows that you're serious, shows that you're actually making a decision, that you're not going to move to the next place in 6 months or 1 year, that you really understand what you're looking to, and you know it can fire back, and the company will understand that you're not really, you somehow sneak into the interviews. I don't think that is what's going to happen. I think that that's really something that you need to consider. Next, a lot of us, okay, ignore the data in data science. Okay, so if I look at this, who here knows this? Have seen this diagram of data science? Okay, so most, okay, describes data science as the intersect of computer science, math, statistics, and subject matter expertise. What I'm saying is that all of us are saying, oh, subject matter expertise, I learned that, I will learn that on the job, okay? But what this usually means, and it's true, but there's also a big part of data analysis, understanding, that's missing here. And you might say that this is where that fits in, but you need to know how to look at data, okay? And most people that make the transition today, especially software engineers, don't know how to look at data. You haven't done that, okay? And that's something that you need to learn. So all of us know that, I don't know, those in God we trust, all other bring data, without data you're just someone with an opinion. But truly, okay, let's be honest, this is the way most of us treat data. Like, okay, if you torture data long enough, it will confess to anything. Okay? That's wrong. That's totally wrong. This is probably the top mistakes that I see people. Not, it's the biggest limitation that I see people that actually work in the field. This is the field that needs the most work on. Okay, if you look at data, understanding data, know how that works out. So in order to do that, you need to stop running away from data. Okay, and what you're doing in order to learn is working on real problems and building a classifier or a regressor. Okay, stop and say, okay, let's try to see what I can learn with no classifier, with no model, with no algorithm, just visualizations and some basic statistics. Okay. Once you know how to do that, being a data scientist will be much, much simpler. Okay? Another huge field is unsupervised learning. Most of us, when we go and do stuff, even in Kale competitions, we have labeled the data set and we try to get the highest F1 score over. Okay? Unsupervised learning is way cooler. There are much more interesting things you can do with that. In Gong, we work a lot with NLP. NLP is huge, lots of text, lots of insights that you can get from that, lots of intuition that you have about text and those things. Play with those things. Okay, try to see what you can learn from those things. I think these make much more powerful models. Who here thinks that AutoML will replace most data scientists in 5-10 years? Okay. Thank you for being honest, although I write here that we should stop doing that.
It's too much time.
Yeah.
Maybe.
So what I say is that if this is the way you think and you're not making sure that it will not happen, okay, it's going to happen. Okay, you need to see how you're better than just running models. Okay, so when you're trying to improve your model, okay, look for creative ways, not just doing hyper parameter optimization. Okay, with some grid search or whatever. Okay, tuning the parameters, running more models, doing ensembles, doing all of those things is not improving your model. Okay, AutoML will do that way better than you do. Okay, you need to understand the differences and what you can do to improve the model in a different way. So learning how to do proper error analysis of your model. You got a model, awesome. You got awesome scores. Now understand where the model is right and where it's not, and how you can engineer some features to improve it, or how you can get what type of data you need to make it better. More of those things.
I think there is a good point in problem definition. It's not always just maximizing or minimizing something. It's also defining what's important, defining what's the true problem that we're trying to solve.
I totally agree, but wait for your cue because I have it only in 6 slides. Okay, so
I'm impatient.
Yeah.
You know that.
Nati is super right. I will get to that soon. Many people ignore the science in data science. Okay, we need to understand the scientific method. Okay, which I think is key to success in data science projects. Okay, so basically we're trying to learn a phenomenon in the world and fit a model to it. And our model is a hypothesis that's supposed to explain this phenomenon. Okay, but the scientific method, what it tries to do is to always reject the hypothesis and come up with better hypothesis and reiterate over that and improve that all the time. And that's a common practice in data analysis. Okay, you start with looking at your data, and then you build a basic model. Then you try to learn from your basic model about the data again, and go on and on and on. This is the way projects work most of the time. Okay, it's not getting the best model out of the bat, and this is something that I think a lot of people don't really work according to, and don't really follow in the way they work. Another mistake is running KNN with K equals 1. What do I mean by that? Definitely not intuitive. I think that it also relates to people, especially in interviews, but elsewhere as well are looking for the answer. Okay. When I ask people in interviews for the answers, what I see many people do is describe like the closest project that they worked on that seems related. Okay, what they've done over there. They try to take one example, or I've seen a paper that does something like this in this situation. Okay, and we design the questions we ask in interviews in order so it will not be something that your distance to the closest thing that you've probably seen is large. And in order to do that, you need to take different points, and you need to take different features, and you need to, work with a different kernel to a different dimensions of the problem solving. Okay, so the idea in data science is not learning tons of algorithms and then picking the best one, the closest one to the problem that you have. It's dissecting and coming up with these things that can be interwoven together into the best model. Okay, and in order to do that, okay, and this is something many people neglect, I think, you need to build your intuition. You need to explicitly, intentionally try to work on your data science intuition. Even though you're just starting to look at models, it's something that's really important that you try to do. What do I mean by intuition? How I think something like this can work? If you're reading a paper about the new state-of-the-art model that solves a problem, okay, you should care at least as much, probably more, about the base model, the strong baseline that they're beating in this model. Okay, because this is a model that for years probably was considered good, solid, providing good results in different scenarios, and from that model, you'd learn a lot about how to approach things.
More like weeks today.
More like?
Weeks. With the rate of new articles, it's the news.
Oh yeah, you mean, yeah. So yeah, there are a lot of advances, a lot of replacements, and it's really difficult to remain updated, keep updated, and learn about all of those things. But as I said, you're not supposed to know what's the best method, what achieves top of the state-of-the-art result in a certain problem. You need to come up with the concepts that might be useful for this problem, because if you take a problem, you see that in going a lot, that achieves state-of-the-art results in a certain issue, and you try to apply it to your domain, it will not work well most of the time. Okay? You need to find the best one, and the way to get to that is to come up with different ideas and concepts. When you try, and in order to do that, you need to teach yourself to say, I don't know, but I will try. Okay? Many people don't do that in an interview. It sounds obvious, okay? But you're not supposed to know the answers. Okay? It's not really interesting for the interviewer if you know the answer. Okay? Just say, I want to go crazy. And I think that a good way to develop that is when somebody is asking you a question, or preferably when you're preparing and you're asking yourself a question, don't come up with one solution. Come up with at least two different, okay? And this forces you to come up with, okay, I know how this was done. There's probably a different way, different angle, different approach. Let's try to develop that as well. And whenever you think something would work and you're trying and it's not working, in the article they try a method and it's not really performing really well, pay attention to that. That's interesting. I, like Nati, really think that working with people, brainstorming is awesome. You don't really need to write the code, okay? The greatest thing about being a data scientist, statistician in this quote, is that you can play with any problem. Oh, sure, you have data, let me play, okay? And we need to embrace that. Okay, when you have a data set, okay, Nati wrote listed tons of Kaggle competitions. Don't load the data, don't play with that, don't even look at that. I mean, do it for just learning how to work with data, but you can just chat with a friend and say, you know what would be cool? Trying this on this data set, or trying that, or trying what I've seen in this article, but with a twist. Okay, when you're talking to a few people, that's a good way to come up with crazy ideas. And there's an awesome community here of data scientists. Now is a big wind in its sails. And I think that many people would be happy to play ping pong with you, come up with ideas, and chat about things that might make sense for you. When you're coming for an interview, I think that most companies that I know base the questions they ask on what the company actually does. So honestly, I never ask about your thesis, project that you've done, stuff like that. You know about it way better than I do, and you probably talked about it so much that you know how to detail. And honestly, I don't know if what you're saying is what you think or what your supervisor in your master's told you to say because you've heard him present. Okay? I know much more than you probably on the things that I'm working on, and with the rate the field advances, in 1 year you're going to work on things that you're going to be in unmarked territory. And most of the time it will be on day one. Okay, you're going to go to a field that you have no experience with. Okay, it's very rare that you've worked on those things. If you've done your PhD in, I don't know, your you're going to work on something new, and companies hire you for one main reason. Okay, you're very, very smart. Okay, you're going to learn, you're going to advance, and you need to understand that and embrace that. So what I'm saying is, look at what the company is doing, say, okay, these are the problems they're facing, how would I approach that? And do some reading, and do some, replace some ideas, and try to think about cool things that you can do in this regard. If nothing else, it's fun, okay? And if you don't enjoy doing it for the companies that you're interviewing for, you will not enjoy working for that company. Okay, so I think that's something important. Questions so far? Okay, I want to be the outlier, thinking more than the others. Another mistake is using too many layers. What I mean by that, overcomplicating things. Okay? You understand that in the industry, simple is good. You want to create models that just work, not deep learning models, nothing too fancy. Good data scientists with good experience are better in identifying those cases where a simple model would probably do as well or not way off, and it would take a lot less effort, and they would be able to go to the next project faster. Okay, so DNNs are awesome. They're probably one of the things that I'll try to see if it fits to any project, but just make sure that you're not trying to hit anything that you see with DNNs as if it was a nail and you have a hammer. I think that for learning, saying I'm not going to build a network, I'm going to build rules for that, a rule-based model, the simplest decision tree, but these are the features, is a very good exercise in learning how to be a better data scientist. Another mistake is playing in the sandbox for too long. What do I mean by that? Exactly what Nati said. Okay? If you're working on problems that have curated data set, that's clean, that looks good, this is the input, this is the output, now run your model, AutoML already nowadays beats most of them, what I mean most, 95% of human competing on Kaggle. Okay? Simply because it has more resources. But the way you shine as a data scientist, okay, is improving your models and understanding what needs to go into the model. So if we say that the data scientists spend 80% of the time cleaning the data and 20% of the time complaining about cleaning the data, it's not fun cleaning the data, but you need to understand that you need to do that. And what you need to learn to improve is, how do I get to a place where I have the matrix, where the rows are the observations and the columns are the features? Okay, getting to this point, understanding your loss function, understanding the output, understanding the data set and how you're going to create the data set. These are the most important things. Okay? What I usually ask in interviews is, I give a problem, somebody will tell me how the network looks, and then I ask, okay, what do you use for a data set? And then, okay, what do you mean? I need to create my own data set? Yeah. Okay, how do you take it? What do you use? How do you balance those things? How would you divide it between train and test? 80-20 isn't really what you want to do most of the time. Okay, you need to understand how to actually do those things. So there's no good presentation without a tease for Nadi. So I just say that learning data science through Kaggle competition is like learning to play chess through playing backgammon. Okay, you learn a lot, you improve, you learn strategy. Okay, it's fun, it's competitive, but you need to understand that when working on an actual project in the industry, then it's a different game, and you learn all those skills, but they won't really translate. And specifically for Kaggle competitions, this means that your ideas and how they work, and if you are able to improve yourself, are much more important than if you're able to beat the top 5% that probably use tons of GPUs and money in order to get there. Okay, so compete against yourself mostly and exchange ideas. Kaggle has an awesome community with ideas and sharing that you can learn a lot from.
You know about that quote, now that Google has cracked chess and Go, I think it's Google, right? It seems that learning backgammon is pretty much all you need to do to learn chess these days.
I actually prefer backgammon, mostly because I have someone to blame for losing.
It's a game of chance, isn't it?
I've covered most of those things, so I'll move forward. Another mistake, and nowadays many people do that, is trying to oversell yourself. It relates to what you write in your CV, and I'd be happy to give my view on those things later. But I think this really describes how these things look, okay? And it's totally fine that what you do is input chaos, okay? You need to understand that, okay? This is what you want to do, this is what you enjoy doing, or if you're doing something else, make that explicit, okay? And what I mean by that is that when you come in for an interview, your F1 score doesn't need to be 100%. You're not expected to know everything, okay? But if a model has its inner confidence, the weights in the softmax layer, okay? If you're confident about an answer, it needs to be correct, okay? I've rejected candidates that were really strong, but made big mistakes and were totally convinced that they are right on those things, okay? And hired people that they just were really good in knowing what they know and what they don't know, because I knew that these people will become better and learn all the time, okay? So don't come to the interview and say, yeah, and be overconfident. You need to understand that you're going to fit Natia with Israel as well, okay? If you put 5 spelling mistakes in every line of your CV, we would still want to talk with you because people are weird as data scientists. It's basically weird, okay? And you have the credit for that, okay? But the main thing here is that you need to understand that it's okay to say, I don't know, okay? And you should say, I don't know, but I would try when you're not convinced, okay? And as I said, the field is moving really fast, so you need to understand that. You need to learn all the time, even after you got a position, which kind of means that go now for a position that will allow you to learn, allow you to improve, and make the transition with time. You don't need to be now at your final, position, as I said before. A few points about your CV. Okay, I've seen people that list their Coursera courses in equal focus as their undergrad studies or MSc, okay? So I think that's wrong. It's a course, it's an online course, okay? My wife gives online courses. I don't think it's the same level. And even something that I've seen several times, you didn't go to Stanford, let's be honest. Okay? See people list several years in Stanford because they've taken really serious courses online. There's a difference, and that's a bit overselling, okay? It's like a signal that you think that these courses taught you everything that you need to know, and they're equivalent to somebody spending 3-4 years learning math physics, statistics, and even, I don't know, biology or things like that. One other thing, your CV is not the same as the requirements file of a Python package, okay? Don't list SciPy, NumPy, Pandas, whatever, okay? Focus on projects, focus, not even on tools, okay? It's not like you know to do regression, SVM, and you know how to solve problems. You try to convey that you know how to take a problem and solve it in many different ways, and you have different tools. And I think that.
Can I cover the when there's a job environment and you say you need to know pandas and NumPy and etc. And I heard somewhere that you need to write in your CV what's written on the ad. So how does it
I'd be blunt when you see a job position like that, swipe left, swipe left. Seriously, and I'm not, really saying that, because a lot of the time the people that drive that are some people with the HR or stuff. You don't want to work at a company that honestly the person that would be your manager say, okay, she knows PyTorch, so I take her to the job, and she doesn't know PyTorch, she just knows Dynet. Okay, these are tools. Okay, you understand the concept, you understand all those things. So I don't know. I can tell you just from my point of view. I don't write those things. If I would have and you would write them, I wouldn't know, because it's just the basic. You need to know how to solve problems. Even if you just know R, come prepared. Okay, learn some Python. But even if you don't know Python, you would learn that really quickly. I teach that in Bar-Ilan, where I teach in 3 hours. Okay, and students and people. It's not obviously not to the level that you need, but you're very smart. You learn how to do that. Okay, but I think that maybe it's something that's not very related. But I see a lot of people asking, should I do masters? Should I have a PhD? Should whatever? And in order to get into data science. The main reason for doing those things is that you get experience in research. That you take a problem that nobody cleaned and worked on and defined and stuff like that, and you do your own research. And masters and PhD allow you to do that and to spend the time on that. Okay, this is, I think, is the big difference. Now, if you learn to do that elsewhere in the industry, that's great. Okay, that's even sometimes more useful. And I think that even if you haven't, this is what you need to learn to do. Work with different projects. And one other thing is just know that it's totally doable and okay, and that you're definitely at a good position. Seriously, we're looking for very strong candidates. There aren't a lot of people to fill the demand. You're in control. Learn, come prepared, but you can totally waste the interviews. And obviously, I'd be happy to connect with LinkedIn and Facebook with everybody. We're hiring to different positions, so ping me and bring your friends. And thank you. Questions, or should we move? Yeah.
My question is, how important is, in your opinion, to choose the domain of the first position, meaning if it's finance or